Picture this. It's 2025. You're taking that trip you've always wanted to. You know, the one to that faraway place, but you haven't been yet since you're not sure how to get around. It's a different country after all. What if you had reliable access to a standard transportation that wouldn't leave you stuck in traffic all day? Group 25 is here to make your visions a reality. We're here to help you launch a standardized, eco-friendly, and affordable transportation option for the global marketplace. Not only will e-scooters provide a fun and safe, reliable transportation, but they'll also help reduce the human carbon footprint. How great is that? One problem: where should we go first? That's why you made the right choice by coming to Group 25. We've analyzed 2 years of bike sharing data to make sure you make smart choices. Before reviewing the data you provided us, Group 25 came up with some hypotheses to make sure that we lead you the right way. According to Motion Digest's article on global e-bicycle sharing, the market for e-bikes has continued to grow by steady amounts over the past decade. Countries that currently experience significant air pollution have been turning to alternative transportation means to reduce greenhouse gases, as well as improve traffic congestion. We expect that the correct combination of climate and seasonality, as well as more working days when traffic is worse, will lead to increased rides in future markets. Although we suspect certain trends to be apparent, it's important to note that there are several assumptions and heuristics that we must take into account. What options are available for transportation in the country? How do current and future policies and laws affect the ride-sharing market? How was the original data collected, along with the assumption that customers who ride bikes also ride scooters? For our timetable, we assume that Monday through Friday is the work week, the variation in number of holidays in a given country is negligible, and that the domestic market data applies on the global scale. The data set provided allows us a wide range of options. The first step in our analysis is to learn about each numerical variable. The perceived temperature, humidity, wind speed, casual versus registered riders, and total bikes are the ones that we'll be focusing on for the numerical variables. The following slide will provide the test for normality, letting the group know how to manipulate the variables in the future. Afterwards, the categorical variable descriptives are collected. So, a frequency analysis of each continuous variable shows that no variables are normal, however, humidity is close. For example, looking at wind speed here, we see a high positive skewness leading to a shift left, indicating the majority of data was collected at lower wind speeds. The graph also helps to highlight outliers such as the point after 0.5, located here. For each categorical variable, the descriptives were charted to easily see where data was collected. For example, for season, the lowest was spring, 1, and the most was fall, 3. This helps so that we can see and compare our data to see when the most riders are going to be out and about. To determine if there is a significant effect of weather, working day, holiday, and wind speed on the total number of bike rides, a correlation analysis was completed. The Pearson correlation, highlighted in red, indicates the extent that the factor has a significant effect on the number of bikes. Therefore, the largest impact here is weather, with a strong negative correlation, implying that as weather deteriorates, the number of rides decrease. This can be applied to wind speed as well, that as wind speed increases, the number of rides decrease. Since it has been determined that weather has the largest impact on the number of rides, let's take a look at what weather is preferred. 63.3% of rides took place during fair weather, number 1. This will be critical when evaluating expansion options. Similar analysis have helped identify that lower wind speeds and moderate temperature are impactful. But where does this lead? What type of rider? Using a linear regression on the type of rider, be it casual or registered, we can see that there's no significant difference between the type of riders. Therefore, we don't care whether you're casual or registered. However, for your benefit, we're going to hope that people are going to be registered because, we want to make money. The ANOVA analysis shows that since the p is greater than 0.05, the null hypothesis must be rejected, and there's a significant difference. With this information, Group 25 is ready to move forward with the conclusions and recommendations. So what did we find out? Well, significant contributors increase the number of rides. An increase in perceived temperature up to a certain point. Once it gets too hot, we actually start losing riders. Lower wind speeds, that always helps, keeps the riders on the bikes and the scooters. And the season affects rides. Fall is more popular. In terms of no significant effect on riders or number of rides that we're expecting, the humidity, the type of rider, and whether it's a working versus holiday versus weekend. For our next steps, Group 25 has determined that a moderate, stable climate with solid road infrastructure and political stability will provide the best future for e-scooters. Based on MarketWatch's outlook on e-bikes and governing laws around this style of ride-sharing, it seems that in the future, China, India, and France are optimal due to investing in greener practices and large populations. Here are our references. Appreciate the support, and we look forward to working with you as we grow the ride-sharing business. Thank you.